Good morning, children. This is class 11th physics. We had done lastly the analytical method for addition of vectors. So this is the summary of it. That is the resultant of two vectors. We know that the resultant formula was r equals to under root of a square plus b square plus 2ab cos theta, right? Now, here are the two cases which are going to describe the maximum resultant, when we will get the maximum resultant and when we will get the minimum resultant. So maximum resultant will be obtained when the angle between the two vectors whose addition we are going to carry out are parallel. The angle is 0 because cos theta will be 1 and you will get a square plus b square plus 2ab cos 0, that is 1. That is a plus b the whole square. And if we remove the under root, we are going to get r value will be maximum, that is a plus b, right? So this is the case when the resultant will be maximum. Now let's see the case when the resultant will be minimum. So children, the resultant will be minimum when the value of the theta will become 180 degree, because cos 180 will give you -1, right? So here you are going to have a minus 2ab. So the formula will be of a square minus 2ab plus b square, that is a minus b the whole square. And if you remove the under root, we are going to get r minimum as a minus b. Whichever is the greater, from the greater you are going to subtract the smaller. So this is the resultant, maximum resultant and minimum resultant. Now let's see a few more properties. That is the vector addition, the what you're adding, that follows the commutative law, right? Means vector a plus vector b is equal to vector b plus a, right children? Next is vector addition also obeys associative law, right? Associative rule, that is vector a plus bracket a plus b equals to bracket a plus b plus c, right? So it obeys the associative law, right? Now next is, if you're having two vectors whose magnitude is same, right, then the resultant will be the bisector. This point we will cover further also. I'll explain you there in detail. Then if you're having vectors with unequal magnitude, then at least minimum you will require, children, 3 vectors for getting the 0 resultant. How, children? For example, you are having 3 vectors a, b and c. Suppose the addition of a and b, the vector addition of a and b, it gives you a quantity, it gives you a vector, that is r. Now, if you want to make this r as 0, if you want to get the resultant as 0, then what you will do? You require one more vector which should be equal to this resultant, plus it should be in the opposite direction. So if it is in opposite direction, you will have a minus sign, and as its magnitude is equal, it would be minus r. So then the resultant will be 0. Yes, children. So for getting the resultant of unequal magnitude vector 0, we require minimum 3 coplanar vectors, means 3 vectors in a plane, right children? Next, suppose you are having 2 vectors here, this is vector A and vector B. The magnitude of vector A is greater than the magnitude of vector B. As you can see, A magnitude is greater as compared to B, right children? So as their magnitude is equal, the resultant vector R, that would be inclined towards the bigger magnitude vector, right? A ka magnitude is bigger as compared to B. So the resultant will be tilted, will be inclined more towards the vector which is having bigger magnitude. So if this is more towards A, then this alpha is less, as R will be more inclined towards A. and this beta will be comparatively more. So if the magnitude of A is greater than the magnitude of B, then the angle that the resultant will make with B will be greater than the angle made by the resultant with A. Right, children? So beta will be greater than alpha. So, and we did, if we are having unequal vectors and non-coplanar plane, means two vectors are somewhere in one plane and others are in some other plane, then for getting zero resultant, we require, children, 4 vectors. Minimum 4 vectors are required. But if they are in same plane, then 3 vectors are required to make the resultant 0. Right, children? Now, this is the point which I was telling you, that if you are having equal magnitude vectors and the angle between them. So children, if we are having two vectors whose magnitude are equal, so here we can see, children, vector A and vector B, their magnitudes are equal. So we are going to talk about the resultant. So resultant will be the bisector, right? So bisector, we know what is a bisector. It is a line which cuts the two into equal, right? It cuts from its center. So similarly, this will be the bisector line, right? This is the bisector of the AB. So this will give you the resultant of two vectors having equal magnitude, right? So this will be the resultant. So its magnitude will be equal to 2a cos theta by 2. This, children, you can just substitute the value in the resultant formula, that is a square plus b square plus 2ab cos theta. So this is your homework. You need to put the value, that is a and b are of same magnitude. So instead of a and b, you can just put x, or you can just put a small a, and finally what you will get, the value of r, as the value of r will be 2a cos theta by 2. This will be the resultant, right, children? So if you are having two vectors of equal magnitude, then the resultant will be the bisector of the two, and its magnitude will be 2a cos theta by 2, which you are going to do today in your homework. Now here we are having one special case, that is if the angle between them, this full angle is 120, right? So if you substitute this value in the resultant formula, then we will get, because cos 120 by 2 is 60, right? Cos 60 is half. So 2 will get cancelled and you will be left with A. So your resultant magnitude is A. Okay. So now we are going to move with the vector subtraction and Lami's theorem. Previously what we have covered is about addition. Now we are going to talk about the subtraction. So children, when you want to subtract two vectors, you are going to treat, suppose you're having two vectors A and B, you want to do the subtraction of them. Then what you will do, you will invert the second vector. So the inversion of the second vector, that is B, will be minus B, right? Uska hum inverse ले लेंगे, right? And then you are going to add, and this will give you the subtraction of the two vectors, because we know, children, addition how we are going to do, by the law of triangle. That would be easy, right? Addition we have done. So for subtraction, we are just going to change the second vector, and instead of taking B, we are going to invert the direction of the second vector, because if we are reversing the direction, then we will get a minus sign, right, children? So here you can see that this is what, this is vector B, and if I require the inverted B, then it would be exactly in the opposite direction, and that would be minus B. And then simply we are going to apply the law of triangle. So we know the resultant formula, that is by using the law of triangle, that is r equals to under root a square plus b square 2ab cos theta, and we know the angle also, that is the resultant angle, that is the angle made by between a and r, that is tan alpha equals to b sin theta upon a plus b cos theta. Right, children? So let us try doing it. So suppose you want to subtract a minus b, then directly we are not going to do a minus b. What we are going to do? We are going to invert it, right? And we are going to put the plus sign only because we want to use the law of triangle. So, right, children? So instead of taking b, we are going to invert it and we are going to use minus b in this. The answer will be the same. As we know, plus minus is minus. So this is one and the same thing, right, children? So let's see how we are going to do this. So this is your vector. This is your vector A. This is a vector B. Inverted of B is minus B. Here we can see, right? Now we are going to apply the law of triangle for this. That is A minus B. A minus B. So you will have A square plus B square minus 2AB cos theta. You will apply this. You will put the values over here, and you are going to easily get the value of A minus B, the magnitude. And for direction, one minute change, and that is a minus b cos theta. We remember that for addition it was a plus b cos theta, and for subtraction we are having a minus sign here and a minus sign here. So only this is the difference. Rest all we are going to apply the law of triangle in this. Right, children? Now there are some important points as we saw in the addition, that it obeys the commutative law. It obeyed the associative law, but here the subtraction does not obey. As we know that commutative law, right? So A minus B is not equal to B minus A. Subtraction, vector subtraction does not obey commutative law. Second, the vector subtraction does not obey associative law. Right, children? And here is one important case, that if you are having two vectors whose magnitude is equal, okay, if the magnitude is equal, then see, children, then you will get this as, let me tell you how this has come. If you solve this, then we will get, this is 2a square minus 2a square cos theta, and you are having the under root of the whole thing, right, children? Now if you take 2a square common, and if you take 2a square out of the under root, what will be left in the under root is 1 minus cos theta, right, children? And if you apply this under root over here, you are going to get under root 2 into a, and this is your trigonometric function, trigonometric formula. Under root of 1 minus cos theta is equal to under root 2 sin theta upon 2. Right, children? This root 2 and root 2 will become 2. So you will have 2a sin theta upon 2. Okay, children? So this has come like this. So your final, if you are having two vectors of equal magnitude, then the subtraction magnitude will be 2a sin theta by 2. Right, children? And here we are having a special case, that is if theta is 60. We know sin 60 is half. So 2 will get cancelled and we are left with a. So a minus we will give you the magnitude as a. That is your vector A and vector B. Let's see a few more points. Here, the fourth point says that if you are having two vectors are such that the subtraction and the difference vectors are having equal magnitude, means if you subtract two vectors or if you add two vectors, your answer is same. Then when is that possible? Means a plus b, vector a plus b magnitude is equal to magnitude of vector a minus b. When is this possible? Right, children? Now we know that the formula for r, right, when you are going to add the two vectors, you are going to have 2, it is under root of a square plus b square plus 2ab cos theta. And for subtraction, we know it is a square plus b square minus 2ab cos theta, right? If the value of theta is 90, then children, you can see that their magnitudes will come out to be same. Okay, the fifth one explains you about null vector. Null vector we have already done, that if a and b, a plus b is equal to a minus b, then your b is a null vector. That is, b is zero vector, right? If the difference of the two unit vectors, we know unit vectors we have done, is another vector, then the angle between them is 60 degree. Okay, the last topic for today is Lami's theorem. This says that if we are having three vectors A, B and C, and if we are representing them in the form of a triangle, in form of the sides of the triangle, and taken in the same order, what does the word meaning of the word taken in the same order mean is, if you start from A, vector A, see you are starting from A, this is the tail and this is the head, and then you move towards B, again tail and head, then you move towards the third side of the triangle, again the tail of C and head of C, toward from the tail of C to head of C. So we are moving in the same order. So if this is the case, that if three vectors can be represented in magnitude and direction by the sides of the triangle taken in the same order, then this can be said that A plus vector B plus vector C equal to 0. Or one more thing can be stated using Lami's theorem, that is, this diagram can be represented in this form also. So here, this is your vector A, and the angle opposite to this is alpha. So A upon sine alpha will be equal to the next vector is vector B. So vector B, and opposite angle is beta, will be equal to B upon sine beta. And third vector is vector C, and the angle opposite to that is R. So will be equal to C upon sine R, where alpha is the angle between B and C, and here we are having vector A, right? So this is the Lami's theorem, very, very important theorem. Okay, children, so this